In this video, I'm going to teach you how you can integrate your hyperbolic secant function. Now, there is more than one way of doing this, so I'm going to run through the way that I think is the easiest. The first step is to recall our basic definition of the secant function, which is 1 over cosine. We can say in exactly the same way that our hyperbolic secant is just going to be 1 over cosh. And we can actually use this to do a slightly different integration because we don't know what the integral of your hyperbolic secant is. So what we can do is we can instead do the integral of 1 over cosh x. Now we need to use some other identities, and we can recall that our cosine squared plus our sine squared equals 1. And when we're thinking about our hyperbolic functions, it just changes to a minus. So our cosh squared x minus sinh squared x equals 1. And if we rearrange that, we can get an expression for cosh squared. This doesn't seem too useful yet, but we can use quite a cunning trick. And we can, instead of doing 1 over cosh x, we can add in an extra cosh. And they're going to cancel out. So it doesn't really matter because the top and the bottom are going to cancel down. You haven't actually changed anything. This now allows us to use our cosh squared identity, and we can simply substitute that in there. So it looks like we've made things a lot more complicated, but in fact, we've set this up in such a way that when we do a u substitution, it's going to do a little bit of magic and work out brilliantly. So we're going to go across to the other side and think about a u substitution. And it turns out that the best thing to do is to let u be your sinh function. Then when you find the derivative of sinh is cosh, and then we rearrange that to get dx equals. And so we've now got everything that you need in order to do some substitutions. So you've got your u here as your sinh function, so you can replace that in there. And then you have dx, which you can replace the dx here with. So we just do that substitution there. So we've now got an integration that is kind of mixed up. You've got some x's and some u's. But the brilliant thing that happens here is that your cosh x cancels. And so when we do that cancellation, we get this. And you may recognize this as something familiar. This is in fact the form that the derivative of your inverse tan takes. So the integral of the derivative of inverse tan is going to give you inverse tan. And we've got u there. We're not really interested in u. So we can look back and see that u equals sinh x. So we can replace this and we get our final answer. This is one possible answer. Alternatively, you can also see the integral written this way. These two are actually identical. There is no difference between those. So you can now integrate your hyperbolic secant function. Hope this video was helpful to you, and thank you very much for watching.